Now on to problem number 3 from this portion. Problem number 3 starts off with giving us this graph, and they tell us that this is the graph of G. And then they say that f is defined as the integral from negative 8 to x of g of t dt. So from this, again, this being the graph of g, I went ahead and figured out what the certain areas were for each one of the partitions. You have an area of negative 2 for this triangle, positive 2 for this triangle. This would be 16 pi over 4, so it's 4 pi. And then this is 8 for that rectangle. You have a rectangle that's 6, a triangle that's 6 here, and then this would be negative 6 again because it's below. The great thing about this problem is that they go, everything is going to be from left to right. So that doesn't normally happen here, but it does, so let's be happy about it. All right, now, from this, they ask about the critical numbers. And what do we know about critical numbers for f? We need f prime to either be 0 or f prime to be undefined. And again, f prime is just g of x. So g of x is never undefined here, so we can only look for where f prime is 0, and f prime is 0 at negative 6, and then here at positive 2. So those are going to be my critical numbers. All right, we've got 1 point so far for getting this portion right, and then for identifying the 2 critical points, we got a point for that. Now let's explain about the local minimum, local maximum, and more detail. Okay, so G goes from negative to positive at negative 6. Therefore, at negative 6, we have a relative or local. I think they refer to them as local in this problem. Yeah, they do. So at negative 6, we have a local minimum. And G goes from positive to negative at 2. Therefore, at 2, we have a local maximum. Now, it's okay to say this for G because we established here that G is equivalent to f prime. So when we say that G goes from negative to positive, that's the same thing as saying f prime goes from negative to positive. So that is what we're looking at here. Okay, on to B. B asks about what is f of 0. Well, f of 0 is the integral from negative 8 to 0 of g of t dt. So that's going to be negative 2 plus 2, and then plus 8 plus 4 pi. So that's just going to be 8 plus 4 pi. So the negative 2, positive 2 cancel each other out. So we get 8 plus 4 pi there. All right, now on to C. This is the limit as x approaches negative 4 of f of x over x squared plus 4x. Now, I would not be shocked at all to see a problem like this appear on this year's AP test. because I have a feeling that they are going to be looking for a lot of written justification. Just because they want to make sure that if you get a 5 on it, you've got a legitimate 5. So they're going to ask you to explain a lot of stuff. And there's a lot of explaining that can go on in a step like this. So I would not be surprised at all to see this appear in one of the questions. So again, I don't know. I have no insight. I have no insight or information or anything like that. It's just I have a feeling about that. But anyway, the limit here. The limit is going to be f of negative 4 over negative 4 squared plus 4 times negative 4. All right, we get 0 in the denominator, and here you got negative 2 to positive 2, so it's 0. So we got 0 over 0. Now that's not undefined. That's just the indeterminate form. And we want to write that down here. We got the indeterminate form here. So from that, I'm going to use L'Hopital's rule. Which says that that would be the limit as x approaches negative 4 of f prime of x over, and then the derivative of the denominator. Remember, it's not a quotient rule here, but the derivative of the denominator is 2x plus 4. All right, so from here, okay, f prime of negative 4 is the same thing. Again, up here we go to f prime, and we said that f prime is the same as g, and g of negative 4 is 2. And then in the denominator, we have 2 times negative 4, negative 8, plus 4 is negative 4, so we get negative 1/2. All right, now the final step here is, I thought I had my other whiteboard in here. Caleb, I hope you took names while I was out of the room. Anyway, this is saying that h of x is equal to g of x over x squared plus 1. And they asked for h prime of 1. Well, that means we need the derivative here. Now, this is not L'Hopital's rule. It's not the derivative of the numerator over the derivative of the denominator. This is the quotient rule. So h prime of x is going to equal to x squared plus 1 times g prime of x minus g of x times 2x, that's the derivative of the denominator, all over x squared plus 1 quantity squared. All right, now from here, h prime of 1 is going to be 1 plus 1 times g prime of 1 minus g of 1 times 2 times 1 over 1 plus 1 quantity squared. All right, so this would be 2 times, all right, g prime of 1, we have a slope of negative 3 right there, so it's 2 times negative 3, minus g of 1, and g of 1 is positive 3, and then times 2 times 1, and this is over 2 squared. So from here, we get negative 6 minus 6, so it's negative 12 over 4, which is negative 3. And that ends this problem. There was a lot involved in this problem. Again, I would not be surprised at all to see L'Hopital's rule appear on this year's test. Again, I can only speculate, but I'm also pretty sure there's going to be some problem on here that's going to involve a graph. So just be ready for that as well. Again, I'll be shortly with question number 4 from this assignment.